Right, thank you very much. Ladies and gentlemen, my name is Helder Marx. I'm Dean of the Faculty of Science here at Wits. And on behalf of Wits University, it is my extreme pleasure to welcome you all to this lecture, the latest in the NRF Science for Society lecture series. The series is an important initiative on behalf of the NRF, because what it really seeks to do is to bridge that divide that's sometimes perceived, sometimes unfortunately real, that exists between science and the community, in order to foster a better understanding and appreciation for what it is that scientists do and the importance of our fundamental product, which is knowledge. And really, this public communication of science is something that we think is extremely important. Now, our attention tonight is on Paleo Anthropology, and we have two speakers which I'll introduce to you very briefly, and then during the radio broadcast itself, a more formal introduction will be made. First is Professor Lee Berger. Lee, you want to stand up? Lee is a research professor in human evolution and, importantly, in the public understanding of science. So I think he's really the ideal person to speak at an event like this. And he's also an explorer in residence at the National Geographic Society. Next to him, Professor Bruce Rubidge, who is Director of the Centre of Excellence in Palaeosciences and is the Interim Director of our Evolutionary Sciences Institute. So ladies and gentlemen, welcome. Welcome to this event, welcome to this university, and I hope you enjoy yourselves.
Thank you very much. Ladies and gentlemen, I'm going to invite to the podium Dr. Berger, who's the Group Executive for Science Engagement and Corporate Relations at the National Research Foundation, and she is the custodian of these programs, to give us an introductory remarks. Thank you.
Good evening, ladies and gentlemen. Thank you very much for responding to an invitation to a lecture that, as soon as we put the topic out there, just draws an instant response. I think it is, we talk about human evolution, but when we just really think about it, it draws an interest that is hard to explain. As the National Research Foundation, we've really placed an emphasis on the importance of science engagement. The National Research Foundation funds especially high-end instruments like the Centers of Excellence and the South African Research Chairs Initiative, where you have top-end, cutting-edge researchers and knowledge generation. What we want to really promote is that these top-end researchers and the kind of knowledge that they produce is made available in an accessible, exciting form to the public, because it is public funding that is helping to generate some of this knowledge in many instances. And so as NRF, we're really proud of this initiative, which is really rolling out in full in this past year, where we've created a partnership between universities, a media platform, in this case radio SAfm, and then the public audiences that we get to, and the scientists themselves. And we've been going around the country, being hosted by different universities, engaging with amazing speakers and getting really good feedback from the audiences. So thank you very much to our two speakers that are going to be engaging with us today, and also with the broader audience that is out there. So I do say do enjoy it. It is always a good experience. Sometimes for some of us, this radio experience is a bit of a disconnect, because we keep forgetting we have to listen to the news and then take sports. But that's part of public engagement, and realizing that the science gets immersed into that particular process. That's exactly what we want to do. I know Wits itself is committed to science engagement. I've spoken to a lot of your researchers and your corporate office who is driving that. So I think we are in a place who welcomes the kind of work and working with NRF in promoting public engagement with the very good science that comes out of your institutions. So thank you very much.
A very good evening to you and welcome to the talk shop on SAfm 104 to 107. I am Masechaba Moshoeshoe. Tonight we are back in Johannesburg, but no, we are not in our studios. We're broadcasting from the National Research Foundation's Science for Society lecture series at the Senate House complex at the University of the Witwatersrand, and we'll be looking at Palaeosciences. The National Research Foundation's Science for Society lecture series is delving into paleontology tonight under the title Palaeoscience Charts the Course of Humanity's Past. As per usual, a bit later on after the presentations, we will be taking your calls on 0891 104 207, 0891 104 207, or you can SMS us on 34701. SMS number is 34701, and SMSs are charged at R2. Palaeoscience, like the subject it studies, evolves as new information on the origins of humanity is unearthed. The further we advance in our quest for answers, the stronger our links to the past, present, and the future become. It will all be clear later on tonight after our speakers have spoken. We're joined by Professor Bruce Rubidge, Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of the Witwatersrand. Also joining us is Professor Lee R. Berger, Research Professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of the Witwatersrand. As per normal, at the lectures we will have presentations from our guests and thereafter open up the floor for our audience here at Wits University and for you at home via SMS and calls to engage. Again, our number is 0891 104 207 or SMS 34701. SMS number is 34701 and SMSs are charged at R2. When we come back, I'll introduce you formally to our guests. The Center of Excellence for the Palaeosciences is the 9th in the program since its launch in 2004. So tonight we're going to be hearing about fossil hominid sites. We'll also be hearing about Australopithecus sediba. I'm looking forward to that. And we'll also be talking about how we move forward as a society, as a community, taking into account where we come from and what these fossils are teaching us about what was taking place in the past and how we can offset some of the challenges then today or deal with the challenges that we're facing today. Our first guest speaker is Professor Bruce Rubidge. He is Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of the Witwatersrand. Professor Rubidge has administered and sponsored research on the Cenozoic fossil hominid sites in the cradle of humankind and supervised postgraduate geology and paleontology students researching the Devonian rocks of the Cape supergroup, as well as worked on research projects relating to the paleontology, sedimentology, stratigraphy, and basin analysis of the Permian-Jurassic Karoo supergroup. He is a former head of the Karoo Paleontology Department at the National Museum in Bloemfontein and is the director of the Bernard Price Institute for Paleontological Research at Wits. Before you start, Professor Rubidge, just a quick reminder that these are the Science for Society lectures. So please bear with us and stay with us. All right, Professor Rubidge.
Thank you, ladies and gentlemen, for your warm reception. And it's a wonderful opportunity for Lee and I to be engaging with the public of not only here at Wits University in Johannesburg, but also the whole of South Africa, and to tell you a little bit about the excitement of the paleo history of our wonderful country. We've all been told that we're going to be looking at this course of humanity's origins, and you will see from the lecture that I'm going to give that humanity has a very deep origin and starts billions of years ago. This, to show you just a little bit about the excitement of South Africa's fossil heritage, this is a site that we found a week ago down at Sutherland. This is a fossil footprint site. It's 20 meters long, and you can see there's an animal that's walked along here and it's got a tail drag going down there, and if you look at it in close detail, you could see even the the little drag marks of the feet as they drag their claws over the mud in this slide over here. Now that gives you an indication of just some of the exciting things that we've got in South Africa that are new and are found. If we look at the geological time spiral showing the development of the history of the Earth and life on Earth, you will see that Earth originated about 4.5 billion years ago. And if we follow the spiral round and round and round, at about 3.5 billion years ago, we get the earliest evidence of life. And that comes from South Africa. It's found near Barberton. We'll talk about that just now. We go on and on round the spiral, and eventually at about 700 million years ago, we get the earliest multi-celled organisms in the world, and those come from southern Africa. Then we go into the mountains of the Cape supergroup, the folded mountains on the way down to Cape Town, and we find there a remarkable history of invertebrate animals and fishes. And there's a history of fishes that's only just beginning to come out, and I'll talk a little bit about that. Then we move over to the Karoo at about 300 million years ago, and it has an unsurpassed history of the development of reptiles on Earth and the origin of mammals. So you can see we're not at humans yet. Humans come a little bit later. At 180 million years ago, Gondwana breaks apart. Southern Africa separates from the rest of the world, or Africa separates from the rest of the world. There's not much of a deposition history in South Africa. And then, in the end, at about 3 million years ago, in these cave deposits in the cradle of humankind, what Lee's going to be telling you about, we've got a remarkable story of human origins. So human origins come from 3.5 billion years ago, but go through many stages along the way. If we look at the origin of life in Barberton, that's what life started as, primitive blue-green algae and microscopic organisms. Then we jump a couple of billion years to the Cape supergroup, these folded mountains that we see on the way down to Cape Town, and you could see this early fish from there. This is an early jawless fish. It comes from near the Cederberg, and you can see the eye, the backbone over there. We still have modern jawless fish today. They are the most primitive of fish, and you could see in the modern lamprey, which has a sucker and a rasping tongue around a mouth, and it simply bores its way into its prey and then sucks out its juices, I suppose, is the easiest way to term how it lives. And Dr. Robert Guest, who was a student of mine a couple of years ago at Wits, discovered this remarkable fossil down at Grahamstown. Now, I know that our listeners can't see this, but if you look closely at this, it's a little fish, the length of your first digit of your thumb, and the front is an oral sucker, and there's some gill slits over there, and this is the oldest fossil lamprey in the world. It comes from Grahamstown. Some people might say that Grahamstown has the oldest parasites in the world. Then we move into this paleontological wonderland, and that is the rocks of the Karoo. They cover 2/3 of the surface of South Africa, extending right from Laingsburg up to Gauteng. And what is important about them is they cover a history from 300 million years ago in the oldest rocks to 180 million years ago in the youngest rocks. So they cover a history of about 120 million years. And it's largely unbroken. And because these rocks are very full of fossils, we can chart the development of life of the various types of fossils found over that extended period, particularly the reptiles. Do you want me to do something?
Professor Rubidge, sincere apologies. We're just swapping mics because we have been made aware that it's not very audible. That one was better.
South Africa has a remarkable history of reptile origins. Now, modern reptiles fall into 3 groups, depending on the number of holes you've got in your head behind your eyes. So if you've got no holes in your head behind your eyes, then you're an anapsid. If you've got 2 holes in your head behind your eye, you're a diapsid. And then modern diapsids include lizards and snakes and birds and dinosaurs. Dinosaurs being not modern, but being represented by birds. And then the synapsids, which have only one opening behind the eye. And mammals belong to that, and we are all synapsids as well. So all of these lineages originated in the Karoo in South Africa. We have the anapsids, the diapsids and the synapsids, and the time of deposition from the Karoo was from 300 million years ago to 180 million years ago. And this whole diversification of all of these different groups occurred or is recorded here in South Africa. Looking at the first group, the anapsids, the tortoise ancestors, this little creature with its very broad ribs is considered to be the most distant ancestor of tortoises. It was considered that way in the early part of the century when it was first discovered, but many scientists did not agree with it. More recently, with the aid of these two American scientists, Tyler Lyson and Gabe Beaver over there, who joined our group of scientists working with us in the Karoo, we've established that this is actually the most distant ancestor of tortoises known, and that's by looking at various embryological features of modern tortoises and comparing it with this fossil one. On the dinosaur line, in the Eastern Free State, we have a remarkable history of dinosaur origins in the Golden Gate sandstones and the red mudstones below that, some of the oldest dinosaurs known in the world. A couple of years ago, Professor James Kitching, who worked here at Wits University for more than 53 years, discovered a nest of eggs near Golden Gate, with a little dinosaur embryo preserved in one of them. Those are the oldest dinosaur eggs in the world. More recently, working with scientists from the University of Toronto, we found another nest of eggs, this one with 28 eggs preserved in it. And those in the audience here can see this wonderful nest of eggs preserved over here. There's the mommy of these baby dinosaurs. And current research being done at the moment by our students at Wits University and by Dr. Jonas Schwannier, by scanning the bones of this thing, we've been able to look right into the structures inside the bones and also the brain cavity of this dinosaur. That's the picture. The oldest dinosaur in the world looking after her little babies. And we've actually found the footprints of the babies around those nests as well. Just an exciting development this year. Dr. Jonas Schwannier doing an excavation near Maclear, where he found this new species of dinosaur, the hand just being exposed earlier this year. And I think watch this space for what happens in the future. But then the line that I want to actually tell you about is the line leading towards mammals, of which South Africa has the richest record in the world. This one that you see on the screen in front of you, with all these different teeth, is a Gorgonopsian. This is our most distant ancestor from the Karoo, aged at about 260 million years old. It's a flesh-eating animal, but there were plant-eating animals as well, and completed a whole ecosystem in that time. And right at the top of the Karoo succession, we have the earliest mammals known in the world. This is the one called Megazostrodon, which is only the size of your thumb, is the oldest mammal known in the world. And this particular one is on display at Origin Centre here at Wits University. So what is the picture that we get out of the Karoo? We can follow by following from the earliest rock layers in the Karoo right up to the youngest layers. We can follow the course of evolution of the different ancestors leading towards mammals. And just one characteristic that we can look at is that mammals have a hard bony palate. You and I all have a hard bony palate that separates our mouth from our nose so we can breathe and chew at the same time. Reptiles don't have a hard bony palate. And in the slide that you've got in front of you, the palate bone is that red bone over there. So as you travel through the Karoo, the palate bone gets broader and broader and eventually forms in the middle, as in the mammalian situation. This is a wonderful history that's documented in the country, and there's no other place in the world that has a history so complete of the origin of mammals and ourselves. Some exciting things that come out of these Karoo rocks. Dr. Meryl van der Walt recently completed her PhD on creating a GIS database of all the fossil localities and the fossils from the Karoo. And now, using this information, we can look at the distribution of these different animals throughout the Karoo. And we've got now a map showing the distribution of different species. So the different colors that you see in the map in front of you is the distribution of different species of animals that have lived in the past, but over a long time period, starting over here at about 280 million years, going to 180 million years over there. And now what is important about that is, at that stage, South Africa was linked to all the other countries of the world. But an exciting development just in the last year is that we've found volcanic ashes with each one of these zones, and we've been able to date them and put a date onto each one of these zones. So, and the dates you can see are remarkably accurate when you consider the time period. This date, the oldest date that we've got over here, 261.275 million years, plus or minus 0.02 million. I think it's remarkable accuracy for that length of time. And it's the first time that these different zones in the Karoo have been dated. And because we were linked to the other countries of the world, other countries of Gondwana at that stage, we can now use this information to date other rock sequences right around the world as well. But the other exciting part of this development is that we can actually now work out the tempo of evolution, of how fast evolutionary trades happen through time. And this is a major scientific breakthrough. Just an exciting little thing that we discovered last year. We've been looking at fossil burrows. Now, a burrow is a hole in the ground, but if you want to preserve it as a fossil for millions of years, the only way you can do that is by filling the hole in. And so, if a flood brings in a whole lot of sand or mud or something, then you can fill that and create a plaque. And here you can see at Colesberg, we're excavating one of these fossilized burrows going down here. And when we took it out, it had a spiral shape going down to the bottom. The bottom was a terminal, and in that terminal chamber, we found some bones. And then we scanned those bones with the synchrotron from Grenoble in France, and we found there, in that burrow, two complete skeletons of a little mammal-like reptile lying there curled up, and an amphibian lying next to him. The sort of picture we get from that is the burrow, a little mammal-like reptile lying in the bottom, and an amphibian coming to join him. And this happened 250 million years ago, 252 million years ago. We can talk about how they came to be in the burrow together, a completely different species. A major discovery is that in the last 500 million years, scientists, paleontologists have recognized that there have been 5 major extinction events. That species go extinct at an extraordinary fast rate, and anything from 65 to 95% of species go extinct over a relatively short period. One of them occurred here at 450 million years, one at 370 million years. In the Karoo in South Africa, we have one at 252 million years, and another one at 200 million years, and then the one that whacked out the dinosaurs 65 million years ago. 3 of those extinction events occur and are well represented here in South Africa. And I want to tell you a little bit about a development that we've got to show us another extinction event. This is a group of people that have been working with me in the group for the last 30 years. We've been collecting fossils all around the basin in South Africa. These are the rocks that we're looking at, and we're looking particularly at this interval here. But we're looking at a 2-kilometer section of rocks, and we've measured these around the basin. My postdoctoral fellow, Michael Day, has done measured stratigraphic sections right from Grahamstown, Prince Albert, Lanesburg, up to Sutherland, and up to the Free State as well.
So where we'd got to was we'd looked at the whole development of life on Earth up until about 250 million years ago, and with the Karoo rocks. And I was pointing out to you that there'd been several extinction events in the world, and that we've discovered a new one which occurs at about 260 million years ago. Because of volcanic ashes, we've been able to date it, and now we are looking at where the different species actually disappear and how long it takes for an extinction event to take place. And that is going to be groundbreaking news and is a thing for the future. And so as I end, I want to just end with the words of Tom Barry and Mike Kluver, who were two famous paleontologist from South Africa, who said South African paleontology is world paleontology, and the research workers of this country who are involved in it have an important duty to ensure that their unique heritage is in their charge is never threatened by neglect, but preserved, recorded, and ultimately reconstructed to serve as a standard world guide to the extinct animals of the prehistoric past. I thank you.